Right, we are back at it again with Java. Mhm. Okay, better. A second short program. Perhaps no other concept is more fundamental to a programming language than that of a variable. As you may know, a variable is a named memory location that may be assigned a value by a program. Right. The value of a variable may be changed during the execution of the program. The next program shows how a variable is declared and how it is assigned a value. The program also illustrates some new aspects of console output. As comments at the top of the program state, you should call this file example2.java. Okay, so we have this. Here's another short example, example2, public static void main. Maybe I should just type it in. Alright, so let's go here, Java, reach reference, first simple program, what is it? Second short program, second short program. Okay, so we will create a new file called example2.java. Let me open it up. Okay, in here I'm going to here is another short example of this file 2.java. Here we have class example 2 public static void string args. Then we declare int num. Okay, this declares a variable called num. This declares a variable called num. Then we have num equals 100. This assigns num the value 100. Okay, then we go system.out.println. This is num. Then we go change the value num times 2. We go system.out.print the value of num times 2 is system.out.println num. Okay, so we will this. Okay, I should use Java C, Java compiler, then Java name of the class. Okay, so this is 2 and the value of num times 2 is 200. Okay, so when you run this program you will see the following output. This is num, the value of num is 200. Let's take a close look at why this output is generated. The first new line in the program is shown here, int. This declares the variable. This line declares an integer variable called num. Java, like most other language, requires that variable be declared before they are used. Okay. Following is a general form of a variable declaration: type and var_name. Here type specifies the type of variable being declared, and var_name is the name of the variable. If you want to declare more than one variable of the specified type, you may use a comma separated list of variable names. Okay. Comma separated. Java defines several data types including integer, character, and floating point. The keyword int specifies an integer type. Okay. In the program, the line num equals 100, this assigns in the program the line assigns num the value 100. In Java, the assignment operator is a single equal sign. Okay. The next line of code output the value of num preceded by the string. This is num. Okay, in this statement, let me just come here. Okay. In this statement, the plus sign causes the value of num to be appended to the string that precedes it. Okay. And then the resulting string is output. Actually, num is first converted from integer to its string equivalent and then concatenated with the string that precedes it. This process is described later in the book. Okay. The approach can be generalized. Using the plus operator, you can join together as many items as you want within the single print line. Okay. The next line of code assigns num the value of num times 2. Like most other languages, Java uses the asterisk operator to indicate multiplication. After this line executes, num will contain the value 200. Here are the next two lines. Several new things are occurring here. First, the built-in method print is used to display the string. The string is not followed by a new line. This means when the next output is generated, it will start on the same line. Okay. The print method is just like println except that it does not output a new line character after each call. Now look at println. Notice that num is used by itself. Both print and println can be used to output value of any Java's built-in type. Okay. Two control statements. Although chapter 5 will look closely at control statements, two are briefly introduced here so that they can be used in example programs in chapter 3 and 4. They will also help illustrate an important aspect of Java blocks of code, the if statement. The Java if statement works much like the if statement in any other language. It determines the flow of execution based on whether some condition is true or false. So this is the syntax. Here, condition is a Boolean expression. A Boolean expression is one that evaluates to either true or false. If condition is true, then statement is executed. If condition is false, then the statement is bypassed. Okay, so here is if num is less than 100, system.out.print num is less than 100. In this case, if num contains a value that is less than 100, the conditional expression is true, and println will execute. If num contains a value greater than or equal to 100, then the println method is bypassed. Okay. As you will see in chapter 4, Java defines a full complement of relational operators which may be used in a conditional expression. Here are a few: less than, greater than, equal to. Notice that the test for equality is a double equal sign. Wait. Okay. Demonstrate the if statement. Okay, so let's go and type it in. Okay, we will create 3 if demonstration. We will make a new file called fsample.java, and let's open it in 20++. Okay, so I got this. Demonstrate the if. Demonstrates the if. And then we have call this file fsample.java. So we will have a class called fsample. Public static void main string args. Then we have int x comma y, x equals 10, y equals 20. And then we have if x is less than y, print system x is less than y. Okay, if x is less than y, system on line x is less than y. We go x equals x times 2. Then we go if x equals y, x now equal to y. X now equal to y. Alright, and then x equal, then we again multiply 2 if x greater than y. No. I can just done. X now greater than x now greater than y. this won't display anything. X equals 1. Now the print line won't see this. Okay. Java C sample.java f sample. Right. Okay. Great. Okay, now we move on to the for loop. Loop statements are an important part of nearly any programming language because they provide a way to repeatedly execute some task. As we will see in chapter 5, Java supplies a powerful assortment of loop constructs. Perhaps the most versatile is the for loop. The simplest form of the for loop is shown here. So we have for, initialization, condition, iteration, and then statement. In its most common form, the initialization portion of the loop sets a loop control variable to an initial value. The condition is a Boolean expression that tests the loop control variable. If the outcome of the test is true, statement executes and the for loop continues to iterate. If it is false, the loop terminates. The iteration expression determines how the loop control variable is changed each time the loop iterates. Okay. Okay, so this is a quick demonstration. I can just do it here. Make a new file called for test, right? For test. We feed it with this. Clear. Yes, works. Yes, yes, also works. Okay, so I'll make a new file called for test.java. Then we open it up. This is demonstrates the for loop and call this file for test.java. We declare a class for test, public static void main string args. Then we declare x equals 0, x is less than 10, and x equals x plus 1. Then we go system.out.println. This is x plus x, and we should run this. Java class name, right? Okay. In this example, x is the loop control variable. It is initialized to 0 in the initialization portion of the for loop. At the start of each iteration, including the first one, the conditional test x less than 10 is performed. If the outcome of the test is true, the println statement is executed, and then iteration portion of the loop is executed, okay, which increases x by 1. Okay. So it is initialized to 0. Okay, so iteration happens after the statement is executed, right? Of the for at the start of each iteration, the conditional test, the outcome, then we execute the statement, and then the iteration portion of the loop. This process continues until the conditional test is false. As a point of interest, in professionally written Java programs, you will almost never see the iteration portion of the loop written as shown in the preceding program. That is, you will seldom see the statement like this, x equals x. The reason is that Java includes a special increment operator which performs this operation more efficiently. The increment operator is plus plus, that is two big pluses. Okay, so they have an increment operator that is used. Now includes a, that is to sign back to back. The increment operator increases its operand by 1. By use of the increment operator, the preceding statement can be written like this. Okay, this thus the for in preceding program will usually be written like this. Okay. You might want to try this, as you will see the loop still runs exactly the same. Java also provides a decrement operator which is specified. This operator decreases its operand by 1. Okay. Using blocks of code. Using blocks of code. Okay. Java allows two or more statements to be grouped into blocks of code, also called code blocks. This is done by enclosing the statement between opening and closing curly braces. Once a block of code has been created, it becomes a logical unit that can be used any place that a single statement can. For example, a block of code can be a target. Okay, once a block of code has been created, it becomes a logical unit that can be used any place that a single statement can. Okay. Here, if x is less than y, then both statements inside the block will be executed. Thus, the two statements inside the block form a logical unit, and one statement cannot execute without the other also executing. Okay, so executing. Right. The key point here is that whenever you need to logically link two or more statements, you do so by creating a block. Okay. Let's look at another example. The following program uses a block of code as a target. Okay. Demonstrate a block of code. Call this file block test.java. We have this. Then we have x and y. Y is 20. Then we say the target. The target of the loop is a block. For x equals to 0, x should be less than 10. We say x and then we print y, but we decrement y by 2. Okay, so let me do. Okay, let's create a new file. Let's call file block test. Then we cd to file block test.java. Demonstrates a block of code. Demonstrates a block of code. Then we have call this file blocktest.java, and then we have block test public static void main string args. Then we declare two variables x and y. We define y is 20, and then we start a for loop. X is 0, x should be less than 10, and x plus plus. Then we go dot print line. This is x and system.out.println. This is y, and we decrement y by 2. Okay, Java block test. Okay, so we get the following output. Okay, so we have, in this case, the target of the for loop is a block of code and not just a single statement, right? The block of code and not just a single statement. Thus, each time the loop iterates, the 3 statements inside the block will be executed. This fact is of course evidenced by the output generated by the program. As we will see later in this book, blocks of code have additional properties and uses. However, the main reason for their existence is to create a logical inseparable unit of code. Okay. So we go. Okay, so this is right. Okay. Lexical issues. Now that you have seen several short Java programs, it is time to more formally describe the atomic elements of Java. Java programs are a collection of white spaces, identifiers, literals, comments, operators, separators, and keywords. Okay, so collection of these comment operators, separators, and keyword. The operators are described in the next chapter, the others are described next. White space. Java is a free-form language. This means you do not need to follow any special indentation rules. Okay. To follow any special indentation rule. For example, the example program could have been written all on one line in any other strange way you felt like typing it, as long as there was at least one white space character between each token that was not already delineated by an operator or separator. Java white spaces include space, tab, new line, or form feed. Okay. Then we move on to identifiers. Identifiers are used to name things. Identifiers are used to name things such as classes, variables, and methods. Okay. An identifier may be any descriptive sequence of uppercase and lowercase letters, numbers, or the underscore, and $sign character. Okay. But nobody uses $sign character except in, I think, PHP. Okay. They must not begin with a number, lest they be confused with a numeric neutral. Right. They must not begin with a number. Again, Java is case sensitive, so value is different from value. Sensitive. Okay, in these are some example of valid: average temperature count, effort, and this is okay. Valid to high temp, not okay. The underscore cannot be used by itself as an identifier. Okay, but in C++ it works. Okay, then we move on to literals. Literals. A constant value in Java is created by using a literal representation of it. Okay, 198.6. That's left to right. The first literal specifies an integer, the next is the floating point value, the third is a character constant, and the last is a string. A literal can be used anywhere a value of its type is allowed. Okay. Type is allowed. Then we move on to comments. As mentioned, there are three types of comments defined by Java. You have already seen two single line and multi-line. The third type is called documentation comment. This type of comment is used to produce an HTML file that documents your program. Okay. The documentation comments begins with a and ends. The documentation comments are explained in appendix A. Okay, so maybe I'll go read that. Okay, then we have separators. Let's move it here. As separators. In Java, there are few characters that are used as separators. The most commonly used separator in Java is the semicolon. As you have seen, it is often used to terminate. Okay, separators that can separate. As you have seen, it is often used to terminate statements. Separators, we have parentheses used to contain list of parameters in method definition and invocation. Also used for defining precedence in expression containing yeah, right. Used for defining precedence in expressions containing expression in control statement and surrounding cast types, right? And we have braces used to contain value of automatically initialized arrays. Also used to define a block of code for classes, method, and local scopes. Right. And we have brackets used to declare array types. Also used when dereferencing array values. Right. And we have semicolon, terminate statement, comma, separates consecutive identifiers and a variable declaration. Also used to chain statements together inside a for loop, inside a for statement. When a chain statements, I don't know, man. I would have to look into that. Maybe it will show it differently. Okay, then we have a period used to separate package names in the sub-packaging classes. Right. Package names also used to separate a variable or method from a reference variable. Colons used to create a method or constructor reference. Okay. Then ellipses indicate a variable arity parameter. I don't know. Ampersand begins an annotation. And we move on to Java keywords. Okay, so there are 61 keywords currently defined in Java language. These keywords combined with the syntax of the operators and separators form the foundation. We abstract, assert, boolean, break, byte, case, catch, char, class, const, continue, default, do, double, else, enum. Okay, we have enum, exports, extends, final, finally, Float for go to if implements import instance of int interface long module native new open opens package private protected provides public requires return short static strict fp super okay switch synchronize this throws to transient transitive try uses void volatile while with okay what does it create creates such Java language. In general, these keywords cannot be used as identifiers, meaning that they cannot be used as names for a variable, class, or method. The exception to the rule are context sensitive keywords added by JDK 9 to support modules. Okay, we'll see that later. See chapter 16 for today. Also, beginning with JDK 9, an underscore by itself is considered a keyword in order to prevent its use as the name of something in your program. Okay. The keyword const and goto are reserved but not used. In the early days of Java, several other keywords were reserved for possible future use. However, the current specification for Java defines only the keywords shown in table 2.1. Okay, const. So we can use them or not. I don't know. In addition to keywords, Java reserves 4 other names. 3 have been part of Java from the start, true, false, null. These are values defined by Java. You may not use these words for the names of variables, classes, and so on. Beginning with JDK 10, the word var has been added as a context-sensitive reserved type name. Okay, so we'll see that as well. Then we have Java class libraries. The sample programs shown in this chapter make use of two of Java's built-in method, println and print. As mentioned, these methods are available through system.out. Okay, system is a class predefined by Java. System is a class predefined by Java that is automatically included in your program. In the larger view, Java environment relies on several built-in Java println built-in method as defined. These methods are available through system.out. System is a class predefined by Java that is automatically included in your programs. In the larger view, the Java environment relies on several built-in class libraries that contain many built-in methods that provide support for such things as I/O, string handling, networking, and graphics. The standard classes also provide support for graphical user interfaces. Thus, Java as a totality is a combination of the Java language itself plus its standard classes. As you will see, the class libraries provide much of the functionality that comes with Java. Indeed, part of becoming a Java programmer is learning to use the standard Java classes. Throughout part 1 of this book, various elements of the standard library class methods are described as needed. In part 2, class libraries are described in detail. Okay. Right, so this finishes.